Applications of linear systems. Now we're going to just do a few more examples of how to use linear systems to solve problems that might come up. The first one here, we have a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats each sell for $12.50. The designer spends $1,400 on advertising. So how many hats must the designer sell to break even? So we want the cost, and we want cost to equal the profit. So we want it to balance out, and we want to figure out how many hats she needs to sell in order to do that. So we think about what is the cost or the expense. That's going to be C equals, so cash equals $5.50 per hat, so $5.50 each, plus we have to add on, she's going to advertise her hats for $1,400. So that's the total cost. And now my profit is going to be how much she sells each hat for. So $12.50 per hat. Okay, so we have the cost and the profit. So in this case, we have a set of systems right here. Well, we want the cost to equal the profit, so I'm just going to set these two equations equal to each other. 5.5 H plus 1,400 equals 12.50. And we want to solve for H. So if I want to solve for H, then I need to put my H's together. Minus 5.5 H minus 5.5 H, giving me 1,400 equals 7 H, or 7.0 H. So then I have to divide by my 7, divide by 7, giving me H equals 200 hats. What this means, if she sells 200 hats, then she will break even on her cost, because her cost will equal her profit. That's your final answer. This next example, a local zoo is filling 2 water tanks for the elephant exhibit. One of the water tanks already has 50 gallons of water in it and is filled at a constant rate of 10 gallons per hour. The second water tank already has 29 gallons of water in it, and it is filled at a constant rate of 3 gallons per hour. So, when will the 2 tanks have the same amount of water? So that's the question you need to ask. And then, so when are the 2 tanks equal in amount? And then explain what that means. So we're going to say tank 1. Okay, so tank 1, we're going to have our amount, which is going to equal, starts with 50, and then we're adding 10 gallons per hour. So X is hours, and Y is gallons in my scenario here. So then we have tank 2. So that would be my tank 2 already has 29 gallons of water and is filled at a constant rate added to it at 3 gallons per hour. So now I have a system of equations. So I'm going to just solve it. Since they're both solved equal to y, I'm just going to set them equal to each other. So we want to know when is the first tank equal to the second tank. So I just solve. Subtract 3x giving me 50 plus 7x equals 29. Subtract the 50. Giving me a negative 21 equal to 7x. Divide by 7. So x equals negative 3. So what this means, both tanks will contain the same amount of water at negative 3 hours. But you have to think, does negative 3 hours make sense? Can you have a negative time? So since we cannot have a negative amount of time, we will say that the tanks are never going to have the same amount of water, because the only time they do is at a negative time. So your final answer is right here. Tanks will never contain the same amount of water. And that's your final answer. So those are the last of your notes over applications of linear systems. Go through the practice problems, make sure that these problems make sense. They're a little bit different than the other type. Then you should be ready for your quiz over this material.